Well, first of all, thank you for the opportunity to talk about one of my favorite subjects, shop and field riveting in the historic record. All right, so let's talk a little bit about what riveting is, in case some of you folks are not familiar with it. First of all, if you're in a steel fabrication and you have a couple connection plates, so let's say 2 inches in length or width, it's called a grip. And you contact the rivet manufacturer, tell them that you have a 2-inch grip. They'll check a chart and they'll find that in this case, you're going to have a rivet that's 3.5 inches in length. You heat the rivet with probably anywhere from 18 to 1900 degrees, put it in your connection plates, and then with a holder on or bucking bar that holds the hot rivet in place, you use a shop riveter or a pneumatic field rivet hammer and hammer the second head in. So you'll have equal heads on each rivet. Now the bolt, rivets versus bolts. Rivets come in a circular steel rod with a forged head or manufactured head at one end. For use, it is placed red hot into the hole, about 1/16 inch greater in diameter. The length of the rivet is the distance from the underside of the head to the end of the fresh rivet. The thickness of the material, again, is called the grip. And you take a picture on the right hand is a tension control bolt. That's the anybody that's in steel fabrication or engineering recognize the tension control bolt used in steel fabrication today. We'll talk about the rivet, shop riveting, and field riveting equipment. You take a look at the right-hand corner. Up there at the right hand, you see a large hydraulic riveter. Notice the stairs. It's buried into the floor of the shop. It takes rivets some large sections. And the bottom of the right hand is a riveter, that pneumatic riveter that's usually hung in a crane. And below, on the bottom left, is the Boyer field rivet hammer. And anybody who wants to know a history about the Boyer field rivet hammer, David Simmons of SIA has a great article about the Boyer rivet hammer. And of course, you have the catcher can and a series of rivets. Lost in the fog of industrial time and industrial process in the prefabrication of large shop riveted assemblies, riveted with a pneumatic and hydraulic riveter designed to drive substantial quantities of rivets in massive structure section. There is a history here that's not being told. The history of craftsmen who operate this rivet equipment in large industrial plants to fabricate the legendary riveted structure of the USA. So you take a look here, there's the picture is actually what they refer to as a bowl riveter. It's actually a large pneumatic riveter, drives some pretty substantial rivets in this column section. Field riveting. The hot rivet is pulled from the bed of burning coals, thrown on a high arc and caught in a metal catcher's can. The rivet is grasped with a set of tongs inserted into a hole and a set of connection plates. A bucking bar or pneumatic holder-on slams against the manufactured head of the rivet, holding it in place as a pneumatic field rivet hammer repeatedly strikes the rivet shank, forming it into a convex shaped head. That is a field riveting process. The picture is actually actors. I call this the Hollywood riveting sometimes because that seems to get all the press, the field riveting process. But actually the fellow out there is throwing the rivet. The hot rivet is actually an actor. 2010, we had a group of actors come in to learn how to rivet because they were going to put on a series of shows on TV about the riveting the Empire State Building. They were going to have a bad rivet gang and a good rivet gang and all this. It never came through, but we had a lot of fun training actors how to rivet. This is the most popular portrayal of the rivet process in the media, and could lead many to believe the millions of rivets required to the fabrication of the famous riveted bridges are driven in this way. It is not accurate. This process is a field riveting process used to connect the larger shop riveted sections together at the erection site. And it represents only a modest percentage of the driven rivets in a riveted structure. Here's an example of a field rivet group. This is number 90 Boyer rivet hammer. I notice here in the picture, the fellow where it's located A, he's got actually the rivet hammer. And then you have a Boyer pneumatic holder on. It actually holds the hot rivet in place while the fellow dries it with a rivet hammer. And you can notice a guy in between the two guys with the hats, it looks like the boss, as the coal forge. And the fellow is heating the rivets to supply the rivet gangs with their hot rivets. Shop riveting versus field riveting. There is a stunning lack of knowledge within the engineering community of the shop riveting process versus the field riveting process. This distinction matters. For example, rivets driven with a pneumatic riveting equipment in the fabricating shop have a bearing and shear values greater than rivets driven with a field riveting hammer. And this would have been taken into account in the engineering design. Here's an example of chart. So if you took a look at that 5/8 rivets, shop driven, a single shear is 2,700 pounds per square inch. Notice the bearing at 9/16 is 5,200. But notice the field, much lower. Field rivet driven in the field is, in this case, the same size, 1,800 PSI and 9/16 bearing at 35. So there's a lot of difference between, and actually steel fabricators, when they run an operation in riveting in the shop, would avoid using a hammer, hand hammer, driving rivets because of this value, lower values in shear and bearing. Shop riveting process. So here's again this fellow on the bowl riveter driving the rivets. And on the bottom left-hand corner, and notice this, another example of the hydraulic riveter. This is actually a picture came from a film. It's if you went on YouTube and put in the Empire State Building fabrication, you more than likely it's a great film. It shows the riveting process and the fabrication of these columns for the Empire State Building. Shop riveting was an industrial process used in the prefabrication of large section riveted, shop riveted assemblies riveted with pneumatic hydraulic riveters designed for substantial quantities of rivets in massive structural sections. Here's an example. If you look at the upper right-hand, left-hand corner is the columns for the George Washington Bridge. Know about every square foot of that column has rivets. And on the right-hand corner are the cells for the Golden Gate Bridge. Notice that almost every square foot is just solid rivets, shop-driven rivets. And below is a picture of the tower of the Mackinac Bridge. Mackinac Bridge had 5,851,000 rivets. Most of them are shop-driven rivets. And I think Michigan Department of Transportation for these pictures. It's very hard to get a hold of shop-driven pictures of shop people working. And here's an example of the tower being fabricated and shipped. Oh, they're getting ready to ship. But notice that picture down there on the right. Almost every square foot is solid rivets, shop-driven rivets. The lack of knowledge of the rivet process, gonna move that here. The lack of knowledge of the rivet process extends to the historic record as well. If you were to do an internet search for the number of rivets in the George Washington Bridge or the Golden Gate Bridge, you would get the impression that each of these 20,000-ton towers of the George Washington Bridge and the 22,000-ton towers of the Golden Gate Bridge was held together with a few 100,000 rivets. The word field was soon dropped from the phrase field-driven rivets in the 1937 Golden Gate Bridge historic engineering record. Today, each tower is now commonly recorded as being held together with 600,000 rivets. This number actually only represents the number of field rivets in the connection. The vast majority of the rivets in this bridge are those driven in the shop. Here's the historic record. The rivets were of carbon steel, 1 inch in diameter for the main members, although a few 7/8 rivets were used in the portals. A total of 488,000 field rivets were driven in the New Jersey Tower, 498,000 in the New York Tower. This is from the 1932 American Society of Civil Engineers. There are about 600 field-driven rivets in each tower. The rivets were heated in coal-burning forges located on scaffolding outside the tower and passed to the crews within the towers by pneumatic rivet passers through holes 6.5 inches in diameter and left in the tower web for that purpose. The Golden Gate Bridge Report in 1937, field-driven rivets. Today, this is it. This is what you see. Go on the Golden Gate Bridge Highway and Transportation website. Many rivets were in each tower of the Golden Gate Bridge. There are approximately 600,000 rivets in each tower. If you look at that picture of that tower, that section right there, those cells probably hold 600,000 rivets. If those 22,000-ton towers were riveted with only 600,000 rivets, they'd more than likely fall down. Knowledge base disappears. When the merchant sailing ships were replaced with steam-driven ships, the fleet of sailing ships soon disappeared, with a few famous exceptions at museums. There was no need for large community of engineers and craftsmen to maintain a large commercial and naval fleet of sailing ships. When the riveting process was replaced with welding and bolting and steel fabrication, the large pneumatic riveting machinery and shop knowledge of the riveting process disappeared. Engineers with experience in designing riveted structures no longer needed the expertise for new construction. Knowledge and experience with the riveting process declined. There was no transmission of the knowledge through education to a younger generation of engineers. Yet, unlike the sailing ships, there exists an enormous number of riveted structures still in service in the United States, a vital component of the working infrastructure. The maintenance and preservation of this vast network of riveted structure could be impaired by the lack of knowledge within the engineering community of the shop and field riveting process. I do a lot of traveling, and I was amazed. I often tell people, you take Pittsburgh, New York City, San Francisco, and remove all the riveted structures within those cities how much of it would be left. Yet there's no, it's just like it's totally forgotten. Now there is preservation, some preservation going on. Here's a Cut River Bridge from Michigan. Some of you folks from up north recognize the Cut River Bridge. Actually, the Michigan Department of Transportation actually did some, had replicated riveted sections for the Cut River Bridge. A fellow by the name of Steve Howell. Here's an example of Steve Howell, the hydraulic riveter, and some of the sections he used for riveting, some of the new sections. And quite impressive work. He still continues. I still encourage this replication, rehabilitation parts for bridges. Another issue, no major industrial museum displays riveting. Riveting both in the fabrication plant shop and in field is a vital part of history of important buildings and bridges nationwide. Yet no major industrial museum in the United States has any exhibit on the industrial rivet processes used in the construction of the legendary buildings and bridges in the USA. Many industrial museums are housed in spectacular riveted structures, as you watch the picture you see on the right. Yet nothing is on display to tell the story of their fabrication. Rarely is shop riveting equipment or field riveting equipment part of an exhibit. What's interesting, a couple of years ago, my wife and I were in the UK. I made a 2-week trip in the UK. Beautiful riveted structure. One day I went into this museum. I think it was Manchester. Beautiful riveted columns, riveted beams, just and I told my wife, I said, I bet they got rivets here. I think I got a rivet display here. I ran up to the desk and I asked the lady, says, do you have a rivet display here? Rivet, what's that? I said, your building's riveted. I said, don't feel bad. There's no museum in the United States that has anything on riveting neither. So we need, I'd like to see that change. I talk about it a lot. I'm not making much progress, but we'll try. Now, I do train people to rivet. We put rivet demo. Matter of fact, in another couple of weeks, we're putting a rivet demonstration for students at Lansing Community College. We do it every semester. So rivet demonstrations and training. So you notice this picture at the top. This young lady is actually, she was an architectural student, and the instructor said she was a very quiet, but she got behind that rivet hammer and she was so excited. He said she really was amazed at the rivet process. Those two fellows that's working there are welding instructors, and they've been keeping this thing going. Right now I just sit back and watch them. But about 10 years ago, I introduced it back in Lansing Community College. One more than that, and they do a lot of training and demonstrations. And you might notice the picture on the bottom there, the fellow to far left in the blue shirt is actually the president of Lansing Community College. And I made sure he got trained in with a rivet hammer as soon as he got hired in. And so there's the staff and some of the people. And I also built, you might notice there's a fixture. I actually designed this fixture where you can dry the rivets. And once you dry with the rivets, you unbolt it, take it apart. You take the rivets out, look at it, bolt it back up, and dry some more rivets. One of them. So I actually got a fellow from a Bethlehem museum. He built one of these fixtures and he puts on the rivet demonstrations. And I got a couple more colleges that I'm working with to try to put on some more setup where they're doing rivet demonstrations. So that takes care of my presentation. So I don't know if my time is short or long, but that's all we got.